Hello everyone, I'm going to solve worksheet number 3. Okay, the first part is questions about the conjugate product. Okay, we know that if we have two brackets that one bracket is the conjugate of the other one, so the terms are completely the same, but one term is the opposite of another. So we can simply get the first term powered by 2 minus the second term powered by 2. Okay, let's apply on the first questions. Here we have x minus 2 times x plus 2. So the first term, x, the second term, 2, one with plus, one with minus. So we see that they are the conjugate of each other. Therefore, it will be the first term, which is x powered by 2, minus the second term, which is 2 powered by 2. Therefore, it becomes x squared minus 2 powered by 2, 4. Okay, second one, 2s plus r times 2s minus r. Okay, the first term in the brackets are 2s. The second term they are the same, but one is with plus, one is with minus. Therefore, we can apply the conjugate product. That would be 2s, which is the first term, powered by 2. Always it comes with minus. The second term is r, so powered by 2. Let's simplify it. 2s powered by 2 would be 4s squared. Remember that the power for the bracket as the terms inside, okay, just we have one monomial. 2 and s are multiplied. This power belongs to each one of the variable and the number inside the bracket. So it's gonna be 4s squared minus r powered by 2 is r squared. Remember that this power just works on r. Do not apply it to negative. Okay, next question. Question 3. X plus radical 3 times x minus radical 3. Okay, again, they are the conjugate of each other. So it becomes the first term powered by 2 minus the second term, which is radical 3 powered by 2. It will be x squared minus radical 3 squared. Okay, as we know, if a radical is multiplied by itself, so the radicands are the same, like let's say a triangle, the answer would be the triangle side. Therefore, in this case, radical 3 powered by 2 is radical 3 times radical 3. You can simply write 3, but also if we want to solve it mathematically, it would be radical. The radicands can be multiplied, so 3 times 3, which is radical 9, that is 3. But simply, after having radical 3 multiplied by itself, you could say that that would be 3, because if you follow this rule that I wrote here, you can get 3. Okay, so it will be x squared minus 3. Question 4. Okay, again, the brackets are the conjugate of each other, one with plus, one with minus. The terms are completely the same, so you can say that it is a conjugate product. So that would be the first term powered by 2. So we write radical 3 powered by 2 subtracted by radical 5 powered by 2. Okay, radical 3 powered by 2, as I explained previously, it's going to be 3 minus radical 5 powered by 2 is 5. Therefore, 3 minus 5 is negative 2. Next question, 5. 2 over 3x minus 1 over 2 times 2 over 3x plus 1 over 2. As you see, the brackets are conjugate of each other. Therefore, the first term, which is 2 over 3x powered by 2, minus the second term, which is 1 over 2 powered by 2. Okay, 2 over 3 powered by 2 is 4 over 9. Both numerator and denominator can have a share of this powered by 2. Therefore, that's going to be 4 over 9. Also, we have the variable x, which will be x squared. and minus 1 over 2 powered by 2. So numerator powered by 2, it's 1, and denominator, which is 2 powered by 2, which is going to be 4. So that's the answer for question 1. Now, question 2, square of binomial. Okay, a plus b powered by 2. So if we have a bracket with two terms, that is to the power of 2, it's gonna be the first term powered by 2 plus 2 times the first term times the second term plus the second term powered by 2. Okay, number 1, x minus 7 powered by 2. X is the first term and negative 7 second term. So it will be the first term powered by 2 plus 2 times the first term, which is x, times the second term, which is negative 7. Okay, we are following the formula. Now we've done the middle part. And plus the second term, which is negative 7 powered by 2. Remember to allocate this sign to the second term. So this negative belongs to 7. Okay, now let's simplify it. X powered by 2 is x squared. 2 times x, the result of this product, 2 times x is 2x. So 2x, the result multiplied by negative 7. 2x times negative 7 is negative 14x. And then negative 7 powered by 2. Negative 7 powered by 2 will be positive. 7 powered by 2 is 49. When we say 7 powered by 2, it means 7 times 7, which is 49. Okay, let's apply the formula for the second term, the second question. 2x minus 5 powered by 2. So the first term is 2x powered by 2 plus 2 times the first term, which is 2x, times the second term, which is negative 5, plus the second term, which is negative 5 powered by 2. Okay, the first term, which is 2x powered by 2, the power belongs to each one of them inside the bracket, belongs to 2 and belongs to x. 2 powered by 2 is 4. X powered by 2, x squared. The second one, multiply the first 2, 2 times 2x, 4x. The result, 4x multiplied by negative 5 is negative 20x. Then the last one, negative 5 powered by 2 is positive 25. Okay, let's do the next one. Question 3. The first term is d, the second term negative radical 2. So the first term, which is d powered by 2, plus 2 times the first term, which is d, times the second term, which is negative radical 2, plus the second term, which is negative radical 2, powered by 2. Okay, d squared is, d powered by 2 is d squared. 2 times d is 2d, times negative radical 2 is negative 2 radical 2d. And then negative radical 2 powered by 2 is positive 2. Okay, just take a look at the mid part. 2 times d is 2d. 2d times negative radical 2. The variable d stands at last. 2 times negative radical 2 is negative 2 radical 2, which will be the coefficient of d. Okay, now question 4. Okay, the first term is radical 3x. So radical 3x powered by 2 plus 2 times the first term, which is radical 3x, times the second, which is negative radical 5. Then plus the second term, which is negative radical 5, powered by 2. Okay, radical 3 powered by 2, because this power belongs to each one of them. Do not forget that. Okay, radical 3 powered by 2 is 3. X powered by 2 is x squared. 2 times radical 3x is 2 radical 3x. So if you multiply the first two brackets, 2 times radical 3x is 2 radical 3x. 2 radical 3 times negative radical 5, it will be negative. The 2 stays as 2. Radical 3 times radical 5. Okay, we can multiply the radicands. So we can multiply 3 and 5, which becomes radical 15. And the variable is x. Okay, plus negative radical 5 powered by 2 will be positive. Radical 5 powered by 2 means radical 5 times radical 5, which is 5. Okay, question 5. Radical 3 minus radical 2 powered by 2. Again, the first term is radical 3 powered by 2 plus 2 times the first term, which is radical 3, times the second term, which is negative radical 2, and plus the second term, negative radical 2, powered by 2. Radical 3 powered by 2 is 3, plus 2 radical 3, the first two terms here. 2 times radical 3 is 2 radical 3. Multiplied by negative radical 2, that makes it negative 2 radical. We can multiply the radicands, so 3 times 2, which is radical 6, and plus negative radical 2 powered by 2 will be positive. Radical 2 powered by 2 is 2. Therefore, we have a 3 here, a 2, which we can add them, so it will be 5 minus 2 radical 6. Okay, that's the end of question 2. Let's move on to the second page. Question 3. Products of binomials with common term. Okay, if two brackets are being multiplied and each contains a binomial, but the binomials have one term in common. As you see here, a is repeated in both brackets, so we can consider a to be the common term in the brackets. So b and c are the non-common terms. Therefore, the answer would be the common term powered by 2 plus the sum of non-commons multiplied by the common term, and then plus, as you see here, plus and plus, but here the sum of non-commons times the common term plus the products of non-commons. Okay, let's apply the formula to each one of the given questions. X plus 9 times x plus 1. The common term is x. X is the common term. So common term powered by 2, x squared. Add the non-common ones. 9 plus 1 is 10. So plus 10. 10 multiplied by the common term, which is x, so 10x. Now multiply the non-commons. Now multiply them. 9 times 1 is 9. The next question, I go step by step to see each part and the calculation. So the common term is x in the two brackets. So common term, which is x powered by 2. Then plus the sum of non-common. The non-commons are negative 3 and negative 2. So negative 3 plus negative 2, which is negative 2, multiplied by the common terms, which is x, and then plus the product of non-commons, negative 3 times negative 2. You can simplify it from here. So x powered by 2 is x squared. Negative 3 minus 2 is negative 5 times x is negative 5x. Then negative 3 times negative 2 is positive 6. That's the answer to question 2. Question 3. X minus 7, x plus 4. So the common term is x, and the non-commons are negative 7 and 4. Common term, x squared. Add the non-common ones. Negative 7 plus 4 is negative 3. Multiply it to the common term. So it's negative 3x. And then multiply the non-common. So multiply negative 7 and 4. That's going to be negative 28. Apply the formula for question 4 and 5 as well, the same. Okay, question 4, x squared. Add up the non-common ones. Negative 2 and 12 makes positive 10. Multiply it by the common term, so it's 10x. Positive 12 times negative 2 is negative 24. 5. Common term is x, so it becomes x squared. Add up the non-common ones. 2.5 and negative 1.5 makes 1. So it's going to be 1 times the common term, which is x, so 1x. Now multiply the non-commons. Negative 1.5 times 2.5. It's going to be, you can multiply them. It's going to be negative 3.75. Okay. Question 4. Cube of binomial. Okay, if there is a binomial a plus b powered by 3, we have to follow this formula. Okay. X plus 3. So according to the binomial, the cube of binomial, the first term powered by 3, so x cubed plus 3 times the first term, which is x powered by 2, times the second term, which is 3, plus 3 times the first term itself, times the second term, which is 3 powered by 2, plus the second term, which is 3 powered by 3. Simplify it. X cubed stays x cubed. 3 times 3 is 9, so plus 9x squared, because here is x squared. Then 3 powered by 2 is 9. This is 9. 9 times 3 is 27, times x is 27x. And then the last one, 3 powered by 3, or 3 cubed, will be 27. Apply this formula for the second one, x minus 2 cubed. It's going to be the first term, which is x powered by 3x cubed, plus 3 times the first term squared, times the second term, which is negative 2, plus 3 times the first term itself, times the second term powered by 2, plus the second term, which is negative 2, powered by 3. Simplify it. It's going to be x cubed for the first one. Then 3 times negative 2 is negative 6x squared. So it is done. Then next, negative 2 powered by 2, because priority is with power. Negative 2 powered by 2 is positive 4, times 3, that is 12x. The last one is negative 2 powered by 3, which is negative 8. Question 5, thin and fat product. Okay, let's take a look at this. X minus 2 times x squared plus 2x plus 4. Said that if we have a bracket a plus b times a squared minus AB plus B squared. That makes the thin and fat part. And if we multiply and simplify, what we get is A cubed plus B cubed. And if between A and B here is negative, therefore the second bracket will be positive, and the result comes with negative. So always the result has the sign of the thin part of the product. So okay, thin part of the first question is given x minus 2. The fat part based on the thin part is made. Okay, we're not worried about that because the question says it's a thin and fat product. So it will be the first term powered by 3 minus the second one, which is 2 powered by 3, which would be 8. Next one, the same. So the first term is x, so x cubed minus, because here is minus, if this is minus, the answer is also with minus. 1 powered by 3, which is 1. Next one, x cubed plus 3 cubed. So x cubed, 3 cubed. 3 cubed is 27. Next one, x and 7. So x cubed plus 7 cubed. 7 cubed is 343. Fine, let's move to question 6. Which of the following expression form a perfect square trinomial? We know that a perfect square trinomial is in this form, that if we have a plus b powered by 2, it will be a squared plus 2ab plus b squared. So if we want to know a trinomial is perfect square, we have to see if it's in this form or not. Like the first one, the square root of the first term is t, and here is 3. Check if 2 times t times 3 becomes the middle one or not, becomes 60 or not. The sign is not important. Just the product must be the value of itself, value of the middle one. So 2 times t is 2t times 3 is 60. So yes, therefore, it's a perfect square trinomial, which we can write it as bracket, the square root of the first term, which is t, the sign of the middle one, which is plus, and the square root of the third term, which is 3, and totally powered by 2. Next one, 4x squared. That must be 2x powered by 2 to become 4x squared. 49 is 7. Now check if 2 times 2x times 7 becomes the middle one or not. 2 times 2x is 4x. 4x times 7 is 28x. But the middle one is 56x. So it's not a perfect square trinomial. The last one. Okay, the last one here, we have a number powered by 2, 7 powered by 2. But okay, the first term is not a perfect square. It must be 4x squared. It is not. It is 2. 2 doesn't have a square root. So therefore, the last one also is not a perfect square trinomial. Okay, that is the end of worksheet number 3.